Okay, so we have this water tank and it's emptying with water. We're told that the volume of water leaving the tank can be modelled by the equation dV by dt equals 3e to the negative 2.5 times 10 to the minus 3t. This thing here. Well, now what that differential means is for any time t we could find out the volume of water leaving the tank. So if you wanted to put 10 into that, you'd be able to find out the volume of water leaving the tank at 10 seconds. If you wanted to find out 5 seconds, you could put 5 in, and again you can find out the volume of water leaving the tank after 5 seconds. So we're also told that the water tank is cylindrical. So what does that mean? Well, if the water tank is cylindrical, that means that V is equal to pi r squared h, and just for completeness, let's copy down what dV by dt is. Well, good testing of your standard form, it's 3e to the minus 0.00255t. Okay, so we've established some of the parameters of the question. Now what do we want to find out? Well, we've been asked to find out an expression in terms of t for the rate at which height changes with time. So what we're actually trying to find out really is how this height changes with respect to time. Let's call that h. Okay, and now remember, differentials are all about rates of change, and we're asked to find a certain rate of change, and that is how height is changing with time, i.e. we want to find out dh by dt. And what I'll do is I'll colour that in a bubble to make that stand out. So this is what we want to find out. Now we're asked to use a chain rule. Now you might be thinking, well, there's no function inside a function here, so why are we going to be using the chain rule? And you're right, there isn't a function inside the function, but it's actually just a different application of the chain rule, and that will become more clear later. But let's just get down currently what we understand the chain rule to be. Our chain rule is dy by dx equals, when we introduce the variable u, dy by du multiplied by du by dx. Now, a way of checking that if that's correct is, do your du's cancel here and here? Well, if they do, yes, you get back to dy by dx, you know that your chain rule is correct. Now what we want to do is we want to set up a chain rule, but this time in terms of v's, h's and t's. Now we've only got two differentials at the moment, we need three. We've only got dv by dt and dh by dt, so we need a third one. And now where's that going to come from? Yeah, it's going to come from v equals pi r squared h, because from that we could find dv by dh. Notice how I haven't said we want to find dv by dr or dv by d pi, because pi and r in both these circumstances are constants. So let's just be abundantly clear. So we want to set up a chain rule involving v's, t's and h's. So find a chain rule for v's, h's and t's. Well, first of all, let's find dv by dh. We said v was equal to pi r squared h. So dv by dh equals, well, pi and r squared are just constants, so it just goes to pi r squared, and we know what r equals is 8, so it will go to 64 pi. 8 squared is 64. Okay, so we know dv by dh now. We need to set up a chain rule involving dv by dh, dv by dt, and of course the thing that we want to find, dh by dt. Now you could have a couple of goes of practicing which chain rule is going to work here, because remember what we need to do is we need to set up a chain rule as we have down here in the bottom left hand corner, where our du's or something will cancel. So we need to do a bit of trial and error maybe, or you could probably spot it straight away. Our chain rule that we're going to have here that will make sense is dV by dt equals dV by dH multiplied by dH by dt. Now notice here the dH is cancelled to give back to dV by dt. So let's plug in what we know from this. So 3e to the negative 0.0025t equals dV by dH 64 pi times by dH dt. Now simple rearrangement of this equation will get you dH by dt. dH by dt equals 3e to the negative 0.0025t all over 64 pi. When you put that into your calculator, you come out with 0.0149 e to the negative 0.0025t. So the question asks us to find an expression of how the height changes with time in terms of t, and we've done that exactly there. Now in the last part of the question we're asked to find the rate at which the height of the water is changing after 10 seconds of emptying, and that is just a simple case of putting in 10 seconds into our expression for dH by dt. Going straight into it, we will have dH by dt will equal 0.0149 e to the negative 0.0025, and that's multiplied by 10 because we're after the solution after 10 seconds. When you put that into your calculator, you should come out with 0.0145, and what will our unit be? Well, dV by dt was given in meters cubed per second, so obviously we're working in meters because it's a height per second as it's a rate of change. And if you wanted to, you can convert that into centimeters per second, which would be 1.45 centimeters per second. And what that tells us is after 10 seconds the height of water in that tank is dropping at 1.45 centimeters per second. And that is both parts done. You've applied the chain rule in a real life engineering example.